Hello guys, welcome to Photons, a photoelectric effect and current. Now, what are photons, right? So first, there was a scientist named Max Planck in 1900 who proposed an idea that that radiation are emitted from a source and absorbed in a tiny form of packets known as photons or quanta. So a radiation, when absorbed, it is absorbed in the form of tiny packets known as photons. And each of the packet is known as photon or quantum. And here, yes, this is when quantum physics started to take place. And quantum physics from then on has been applied in many areas, such as to describe the photoelectric effect, de Broglie theory, production of X-rays, machines, etc. So now, well, Max Planck suggested that the energy of the radiation is directly proportional to the frequency of the radiation. That means the more frequency a radiation has, that means the more energy is associated with it. And he introduced a constant, and this constant is known as Planck's constant, and its value is 6.62 into 10 power minus 34 joule per second. This is joule, and this goes down here, actually it's joule second. So here we have to find first of all the mass m and the momentum in terms of h. Now here, well, we have E equals to hf, and also from Einstein's famous equation we have E equals to mc square. So these two energies, if we say that they are the same, then mc square will be equals to hf. So now we have to get momentum, and we know momentum is just equals to mass into velocity. So here mass into velocity, so mc into c equals to hf, or this is momentum equals to hf by c. Now here we know from the wave motion that c is equals to lambda f, and we have f by c, so that means that 1 by lambda is equals to f by c. So overall we get that momentum is equals to h by lambda. This is the relation between the momentum of the radiation in terms of, Planck's constant. Now, time for photoelectric effect. But before photoelectric effect, you have to know what this phi represents. This phi is called a work function. So I'll just tell you the definition first. The work function is the minimum energy required to emit the electrons from the metal surface. So I'll explain it. So here, work function, let's just say it is 5 joule for now. So if you have a frequency of radiation that is, let's say, exactly 5 joule, then the electrons just emerge out of their orbits, right? So this is an orbit. So an electron just emits out of the orbit from the metal surface. Now, let's say you only have 3 joules. Well, it is not enough to overcome the work function, because this is the minimum energy required. You need a minimum of 5 joule to emit the electrons out of their orbits. So what happens is that the 3 joules only make the electrons vibrate in their orbits, but not strong enough to release them from their orbits, right? And of course, if we have a higher amount of energy, well, these electrons will enter out farther and farther away the more energy you have. So that is work function. Now, time for photoelectric effect. Now, it has been observed that, as I said earlier, that when a photon, the photon is struck on a metal surface, right, it releases one electron from their orbit. So basically that is known as photoelectric effect. The phenomenon in which photons knock out the electrons from their orbits from the metal surface after being incident on it is known as, well, photoelectric effect. Now, yeah, I have the figure right here. These are the photons coming in, and when they are incident, the work function absorbs some of the energy, and here they release, and then after that the energy releases those electrons from their orbits from the metal surface, and F is the frequency of those electrons. And here photoelectric current, the electrons thus emitted from those photons are known as photoelectrons. And well, since these photoelectrons move, right, after being knocked out from their orbits, that means they produce some current, which is known as photoelectric current. Well, because since current is just charged by time, and the electrons take some time to get knocked out from their orbit and will travel some distance, that means they take some time to travel that distance, thus producing current, which is known as photoelectric current. This is it for today, and in the next video I'll be doing laws of photoelectric effect. And if you learned something new, please like and subscribe. Thank you.